OCR GCSE Computer Science, Episode 29, Sort Algorithms. In this video, we are going to be looking at the three different types of sorts, so that's the bubble, merge, and insertion, and then we'll be ending on some exam questions. A bubble sort sorts unordered lists. So you start at the beginning of the list. You then compare the first value in the list with the next one up. Now, if the first value is then bigger, you swap the positions of the two values. You then move to the second value in the list, and you keep repeating this until there are no more items to compare. You then go back to the start of the list. So hopefully you can see that in this example here. You're looking at the first value 7 and comparing that to 2. Now you can see that 7 is greater than 2, so you swap. Now then you look at the second value, 7, compare that to 9. Now 7 is smaller than 9, so you stay there. There's no switch. And then the third value, 9, is less than the value 6, so is greater, than the value 6, so you then switch. You look at the fourth value, 9 is still greater than 4, so you switch, and you then have one pass made. So that's the first pass. Now, in a bubble sort, after every pass, the biggest number will always be at the end, then the second biggest will always be at the end, the third biggest, so it starts getting ordered that way. Now let's look at the merge sort. So the merge sort takes a divide and conquer approach. So you divide the unsorted array or list into a sub-array. So each contains a single element. You then take the adjacent pairs of the two single element arrays and merge them together. But as you merge them together, you're sorting them. So this might be a bit difficult to understand, but let's look at the example here. So you can see the list 14, 7, 3, and 12. What you're going to do is you're going to see how many values there are. In this case, there are 4 values. You're going to split that. So there's 2 and 2, and you then split them away. So 14 and 7 and 3 and 12. Now you have 2 and 2 values. You can still split them both. So you can then split them into 1, 1, and 1, 1. So you split the 14 and 7 into 7 and 14, the 3 and 12 into 3 and 12. And now you've split all of them into individual values. What you're going to do is you're going to merge them back together. But as you merge them back together, you're going to put them all in order again. And that's how the merge sort works. And finally, the insertion sort. So the inversion sort it doesn't take a divide and conquer approach. It takes an approach where you're taking the value and inserting it into a new list. Now, if the step one is that if it is the first element, then it's already sorted. So you look at the next element. You're comparing the next element with the first element. And the first element has now made its own list. So with the second, it either goes before that or in front of it, depending on the size. And you keep doing that. You keep inserting from the old list to your new list until it's sorted. So let's look at an example. So you can see here you've got 4, 2, 6, and 0. Imagine this is list 1. This is the list they give you in the question. Now imagine 4 is the first list. So the box in bold, you've now made your own list, a separate list, and it currently has the first value 4 in it. You're then going to take the next value, which is 2, and insert that into your new list where you think it belongs. So in this case, 2 belongs less than 4, so that's why it's behind 4. Now you then move on to the third value and you see where does that fit into your new list, and you keep doing that, and that's the insertion sort. Now let's do some exam question practice. So can you explain one benefit of using an insertion sort over a merge sort on a computer? This is 2 marks. Okay, let's review the answers. So it's actually less complex with code and it's less memory intensive. Thank you so much for watching this video. If you did find it helpful, don't feel free to give it a like and subscribe if you haven't already. Best of luck with your exams and see you soon.